Hey Valley Middle, welcome back to another G67 math video. Tonight we're going to be determining the central angle and constructing circle graphs. Let's start off with a trivia question. The Olympics just started, so here's your Olympic trivia question. How much did the outfit the U.S. Olympic team wore during the opening ceremony cost? We'll be back with the answer to that and a little more after our instruction. Tonight officially we have two targets. I can find the measures of central angles in a circle graph, and I can construct a circle graph. Let's do this thing. All right. In a recent survey of 100 middle schoolers, the following data was collected. Calculate the following central angles and construct a circle graph. So we've got this little survey they did on finding the fave HGTV show. Looks like Tiny House Hunters was 20% of the kids chose that. House Hunters was 30%. Flip or Flop 100%. Property Brothers 35%. So we need to display this. And in order to do that, we have to determine the central angle. The problem is a circle has 360 degrees and we have percentages. It'd be great if the circle had 100 degrees because we could just say, hey, it's 20% of the circle. But no, what we have to do this is determine the central angle. The way I do it is the box. You knew I was going to go there. I like the box. It's very helpful. We know that 20% out of 100% is going to be the same as something out of 360. So what I'm really doing is setting up this ratio proportion that'll find me two equivalent fractions. So 20% out of 100 is like something out of 360. I multiply diagonally 360 times 20%, and then I divide by 100, and I get 72. I know that my first angle is going to be 72 degrees. All right? So then you'd go down to your circle here and you'd go, all right, 72 degrees. Well, this would be a 90 degree. You can see I started with one line here. That would be a 90 degree. So I got to go to 72 degrees. Let's see. You can see this would be 70 degrees. So this would be 72 right there. And I'm going to click in, and I've taken my first slice of the pie here. So tiny houses would have a 72 degree angle that represents 25% of the kids. Okay, let's take a look at the other ones then. Now we have House Hunters at 30%. If you put 30% into the box and you take 360 times 30%, divide by 100%, you'll get 108. Again, I don't want to do this every time, but I want you to understand that we've created two equal fractions here. 30% out of 100 is the same as 108 degrees out of 360 degrees. So I can put in 108. And let's go ahead and do flip or flop too. If this is 30% and flip or flop is 15%, again, we can put it into the box, and it's kind of obvious it'll be half of 30%. Half of 108 is 54 degrees out of the circle. And then the final one, Property Brothers at 35%. If you pop that into the box, 360 times 35%, you divide by 100. Your missing number is 126 degrees. So let's go ahead and put those in. And I ask you to be patient with me tonight. It's hard to use a trackpad and this a digital protractor. But let's do 108. So I got to add in 108 degrees here. Let's see. Usually what I do is I just take and I figured out where it's going to be on the protractor. So this would be 90 degrees. Here's 110, so 108 would be right about there. And then I'm just going to pivot this down. I think I'm going to put the 108 degrees right here. So I'm going to line up that. So now I've got my 108 degrees starting here at 108 and going to 0. And then I think when I click in, I get my 108 degrees. All right, I've already pre-set up some of these things. You'll have to draw them, but I'm trying to save us some time as we work through this example. All right, the next one we have is 54 degrees. I work better when I can see what I'm doing here, so I'm going to go ahead and set up a 54 degree angle. Again, here I'm starting at 0 over here, so this is, let's see, 50 degrees, so 54 would be right here. And then I'm going to pivot that, see if I can't find that 54 degree angle. Let's see, put that on 0 or put that on 54, right about here. There's flip or flop. Now, if we've done this right, the fourth angle should be there at 126 degrees. Now I could take and I could subtract 360 minus 54 minus 108 minus 72 and get 126 as well. But I'm just going to go ahead and check it on the check it and make sure I have 120 degrees. So starting at 126, starting at 0 over here, you can see 120. This is 130, 125. It is at 126 degrees. So I can click that in and get my property, brothers. So at this point then I can minimize my little guy here, and you can see I've got my circle graph. I've determined the central angles. These are the central angles. In other words, there's 360 degrees totally in the pie, and these are the central angles. They represent this part. This one here is wrong. It was 20%, wasn't it? Tiny houses? Yeah, let me just fix that. I'll just have to rewrite that for you. 20%. And do an overlay on there. Okay? All right. We're ready to look at some vocabulary, and we'll work through a couple other examples. I'm sorry this is going to take a little longer when we're working, but I think it'll make it useful for you. You're going to need a protractor tonight, so make sure you grab one of those. All right, just two simple words here. Central angle. That's the angle whose apex or vertex is the center. It's O in this case, of a circle, and whose legs are radii extending from the circle. So here's A and B. So this is a central angle right here. All right. And then a circle graph is just another name for a pie chart. And of course, this is a protractor. So let's look at another example here. Oops, this one here. The table below illustrates the number of pies sold at Baker's Square last Friday evening. Calculate the following central angles and construct a circle graph to display the information. Well, now we don't have percentages, we just have a tally chart. And that's still okay because you can still create a ratio proportion box. So if you add all these pies up, 5 and 5 is 10, here's 16, 19, and 20. I have a total of 20 pies. And so I'm going to set up a ratio proportion. So pumpkin is 5 out of 20 is the same as something out of 360. So you multiply diagonally, 360 times 5, divide by 20, and you've got 90. That makes sense. 90 is a quarter of 360, and 5 is a quarter of 20. So we can come down here and we can go ahead and set up a 90-degree angle, and we can see we've got our pumpkin all ready to go. That was an easy one, the 90s. All right, let's go ahead and pop in the rest of these over here. French apple silk, that's 5 out of 20, so you can clearly see that when I multiply and divide, we've got 90 degrees there, 2. We put French silk in, that's 6 out of 20, and that's going to be 360 times 6 divided by 20 is 108. Banana cream, it's 3 out of 20. It's going to be half of the 108, which is 54 degrees when you multiply and then divide. And sour cream raisin, that's the one I ordered for my dad. I love that one, so did he. 1 out of 20, 360 times 1 divided by 20 is 18 degrees. So we've got a real small slice down there. But I'm sure you can get it, slice pie. All right. Let's go ahead and do these then. We have to do the French apple. That's another 90. That should be pretty simple. So I should be able to just pivot this guy down and click that in. And there's my French apple. And you can see I show that they're 90-degree angles. Those are the central angles. And let's see, what else have we got? We have got 108 for French silk. So let me go back and see if I can find where I put that one. 108 degrees, let's get that first. Get my little cursor out here. There's 100. Oh, I actually have that set. So, can't remember which direction I put it. I'm going to guess that I put it here. There it is. French silk is 108 degrees. All right, let's see. The next one is 54, so I'm going to pivot that back so I can see what I'm doing. Get a 54-degree angle. So here's 40 here. You can see I'm reading the numbers, 40. If you're looking at these outside numbers, that's the obtuse angle. So I'm not looking at this angle. I'm looking at the acute angle here. So here's 40. Here's 50, 54 right there. So I'm just going to pivot that guy around. I'm going to put that right in next to the French silk. So I've got my 90s. I've got my 108 degree here. And that's going to give me problems tonight. It's not going to let me do that, so I'm going to have to pivot this back, and I can get her in. There's my banana cream at 54 degrees, and I still have to do this 18-degree angle down here. Now I think this is what it is right here. The 18 degrees should be that sour cream raisin, but I think it's important to check to make sure we've got the right one here. So let's slide this guy and create an 18-degree angle. You can see I slid that over a little bit by mistake. You got to make sure you keep your protractor in the center. So here's 20, so an 18 would be right about there. And that looks about right. When I pivot that guy down there, you can see it is an 18-degree angle. So I can minimize this and we can take a look at our pie chart. There's my 90-degree angles, which represented 5 pies, or a quarter of the sales each. French silk was 108, that was 6 pies. Banana cream was 3 pies, each of them at 18 degrees was 54 degrees. And then here's that one I got from my dad, that sour cream raisin down there. Okay? All right, we're going to do one more. This time was a little bit different because we didn't have percentiles. First one we had percentiles. This one's going to be a bar graph, and you can still do this. So we have to just construct a circle graph for this set of data. What? All right, but just take a look at it. We can figure out how many total people there were if we add up the total number of votes. We had 4 and 2. That gives me 6. Here's another 6 is 12, and here's 3. So there's really a total of 15 people who voted. And so that's going to become our denominator. And so for cornflakes, there was 4 people who voted for it. So 4 out of 15. So again, I'm just going to set up this ratio proportion box. 4 is out of 15 as what is out of 360 degrees. 2 equal fractions, right? 360 times 4 divided by 15 gives me 96 degrees. So I could pop that in. I take a look at it. Here, this would be a 90-degree angle, right? So let's keep going here. This would be 95. 96 would be right about there. And there, I got it popped in. There's my 96-degree angle. All right, let's do a couple more of these things. So if we take a look at Cheerios, there was only 2 people who voted for Cheerios. Obviously, it wasn't Honey Nut, but pop it into the box, do your thing. You got 48 degrees. All right, so 48 degrees. Let's see, get my deals here. Here would be a 40-degree. This would be 45, 46, 47, 48-degree angle. And let's see, where am I going to put that? How about here? Let me see. There it is. There's my Cheerio slice. Pivot that guy back. All right. We had life. Let's see. Let's get life here. So life had 6 votes out of 15. Pop it into the box, multiply, and then divide. That would be 144 degrees. So let me get my thing here. Here would be a 90-degree angle. Again, I'm starting from over here, 0, 90 degrees, so I need 144. Now I can start looking. Here's 140 degree. So this would be 145. Right there, 144 degrees. So now I got to pivot that and drop that guy in there. So here's my 0, right where the Cheerios left off there. And there's my 108-degree slice. One more, I'm sorry, 144-degree slice of the pie. And the last one was kicks, and there was 3 out of 15 there. So 360 times 3 divided by 15, that should be 72 degrees. So I'm going to pivot this back and set up a 72-degree angle. Here's 80, here's 70, so 71, 72. Let's see if that angle looks right. When I pivot that down, and you can see it fits right in there, 72 degrees. So let's minimize this guy here and construct our serial graph. So kicks was the smallest one here. Nope, Cheerios was the smallest. Cheerios would go up in here. The biggest one was life. We can put that in that slice. Sorry, my Cheerios got moved. And let's see, cornflakes. What was cornflakes? Cornflakes was 4. That was the 96. That's this one right here. I can slide that guy in. I'll move kicks up too. Here's the cornflakes, and here's the kicks. And I put the pictures in because you can find a variety of ways of displaying that data, and you could add in the central angles if you wanted. You could write in a percentage. You could take and set up and show that 4 out of 15 is so much out of 100% and put that into. There's lots of different ways to display it. I just think the ratio proportion box is the easiest way to determine what numbers. It's certainly easiest to determine the central angles. And again, if you wanted to make this into a percentage, it would be no problem. Put 100 here. 3 out of 15 is the same as blank out of 100%. Do the math, multiply diagonally, divide, and you'd have a percentage that you could add here next to the kicks thing. You still have to use 360 to find the central angle because there's not 100 degrees in a circle. There are 360 degrees in a circle. So sometimes you might have to do a double box depending upon the information you want to show. All right, you've been very patient. Go ahead and try this one right here. Your one pause problem. 200 people were asked to choose their favorite topping, pizza topping, determine the central angle, and create a circle graph to display this data. Go ahead, pause it. I see dead people. All right, if you did it right, your graph would have looked like this. It gave you a pretty simple one to do there. You had a 50% and a 25%, because these were out of 200, so really it's 100 out of 200 is the same as something out of 360, and of course you would have gotten 180. So this central angle here is 180 degrees is what you should have determined. This one here would have been a 90-degree central angle because it would have been 50 out of 200 is the same as something out of 360. 90. All right, here's your ticket to the show. Last year, my students' math scores were broken down into the following 3 categories. Homework was 10%, quizzes were 30%, tests were 60%. Determine the central angle for each and create a circle graph to display this data. I'll take a look at that tomorrow. I think it's important for you to see how heavily weighted tests are. And I think when you see it on the circle graph, 60% of a circle, I'll accomplish that goal. All right, a couple of trivia questions to answer. First of all, how much the U.S. Olympic team's outfit cost? $1,512. If you scan down here, I've broken everything down for you. The blazer was $695. Shoes, the Sperry's, I believe they were $350. Jeans, $195. T-shirt, that was kind of a cool striped t-shirt, was $89.50. That's an expensive t-shirt, but it was a really cool looking idea. You're probably saying, hey, who's Heather Miller Koch? Well, I'll show you. This is her right here. I know this Olympian. She's competing in heptathlon, and she went to school. She's my wife's roommate's niece. Great kid from small town Wisconsin. So hopefully by the time you hear this video, she'll have gotten a medal in the Olympics. It would be terrific. She sent this picture last night from the opening ceremonies. The flag bearer himself, Michael Phelps. Pretty cool. Go Heather. Hope win gold. Have a great evening. Bye.